Well, welcome to today's webinar, a DevOps architecture for an Octopus Deploy based pipeline. I'm really excited that you're here with me today. And my name is Jeffrey Palermo. I'm the Chief Architect for ClearMeasure. We're talking about Octopus Deploy today, and Octopus Deploy is the first and most mature product for automated deployments. It makes it easy for orchestrating releases and deploying .NET applications on-premise and in the Azure cloud. And whether you're a current user of Octopus Deploy or merely looking forward to DevOps automation, you need a streamlined DevOps architecture for promotion across pre-production and production environments. And you need to limit who can deploy to production, ensure releases are moving along properly, and that they're tested first, and block the promotion of broken releases. And many teams ask common questions about how to structure deployable application components and how the deployment fits in with other elements in the DevOps pipeline. And so this webinar, we're going to cover that. And we're going to cover the architecture of a complete DevOps pipeline that integrates Octopus Deploy, how you structure the code in your Git version control system. That can have a profound impact on how easy it is to deploy the code, for instance. Key elements of continuous integration on that build also affect the deployment structure. And there's some rules of thumb that, when followed, make the structure of the automated DevOps environment just fall into place nicely. And if you aren't aware of these rules, or if you break them, then you'll continually struggle to achieve those no-touch, no-drama software deployments that you want as an Octopus Deploy user. And so in this quick 30-minute webinar, we want you to be well on your way towards a stress-free software deployment using Octopus Deploy. And so the baseline technology stack that we're going to use today is .NET Core 3 with Visual Studio 2019, SQL Server, Azure pipelines for builds, and Octopus Deploy, and then the Azure cloud. Now, in this webinar, we're talking about architecture, so we're not going to jump in and do code demos and whatnot. We do that plenty in other venues, and if you have any questions about that, just reach out. We've been more than happy to help you with that. But we are focusing on the architecture right now, the pieces that need to be in place in your DevOps environment to be able to move fast, increase quality, deliver quality, and then run your system with confidence. Because Octopus Deploy ultimately is a tool that we want to work for us. And it's integrated with a myriad of other tools that we're going to talk about too. So again, my name is Jeffrey Palermo, your host for this webinar. I'm the Chief Architect of ClearMeasure, and we are a software architecture company specializing in Microsoft and cloud software. Quick logistical aside, I was trying out with subtitles, but looks like the connection didn't stay properly. We'll try that out for the future. Now, there is a Q&A panel that you can ask questions in the Zoom software, and also make sure that you pay attention to the chat window. My webinar assistant, Heather, is going to be providing some resources that I talk about, and kind of any logistical questions you can direct to her. Now, we have, I'm so thrilled. We have a massive amount of people on this webinar. I know it's promoted in all kinds of different channels, and Octopus Deploy promoted it directly as well. And so I know we have a phenomenal amount of people. As you put your questions into the Q&A, I will attempt to work in those naturally into the conversation, regardless of where we are. But my commitment to you is that we won't end the webinar with a heap load of questions. If there's questions, I'll keep going. So let's jump in and go from there. All right, so our webinar is organized like this. We're gonna talk through the objectives that we're all trying to accomplish, talk about DevOps in general and the architecture parts of it. We're gonna go through the 7 key parts of any DevOps environment, regardless of any tools that you're using. Then we're gonna talk about how Octopus Deploy fits in and how it really hangs off of what you do in your build process. And then we'll talk about next steps for how you can make sure to have a successful Octopus Deploy and DevOps implementation. So first, I do want to give you something of value and help you get automated. For those of you who are even doing manual deployments or struggling in this area, I don't want you to continue to be frustrated and sometimes trapped by the software that you work on, the software that always seems to find a way to break upon deployment. And I understand the lost weekends and surprise overtime that sometimes happens due to software deployments going poorly. So at ClearMeasure, we've helped thousands of professionals over 40 countries be better at software and achieve more. And my latest book, .NET DevOps for Azure, it really exposes the secret about how any team can have a fully automated DevOps pipeline by following a concrete 7-stage design. And so here's what you need to do. Number one, read my book. And by the way, I'll give you a free ebook subset of select chapters just for being here today on this webinar. So just send me an email and I'll get it to you. And whether you're watching live or if you're on this and you get the recording, feel free to share it with a coworker and we can send it to them as well. Or you can request it in the chat and Heather can get it to you. Step 2 is really understand those 7 stages of the DevOps pipeline, which is in the book. And you can find the complete book print form from A-Press on Amazon or anywhere books are sold. And then step 3, launch your own .NET DevOps pipeline. Use the public project that we illustrate in the book as a model. Use the architecture that I'm going to be talking about today, and you'll find it in the book. And then integrate all the other tools that are relevant to your software system. If you do this, you will have a fully automated DevOps pipeline targeting the cloud, and that you'll enable you to move faster and with higher quality. In addition, we have another in-person .NET DevOps Bootcamp class in January of 2020. And so that is coming up, and it's January 16th and 17th in Austin, Texas. I happen to be the trainer for this particular class. You can sign up for it. We do have some end of the year discounts available. Get your spot now. They're filling up quick. And also another resource, my DevOps podcast. This podcast is for .NET developers. It's for people targeting Azure, and it's all about how to ship better and operate well. And you can find that on azuredevops.show. It's not just about the Microsoft product that happens to be called Azure DevOps Services, but it is all things DevOps. We're shipping software using the Microsoft platform. So here's the full details of the .NET DevOps Bootcamp. You can find that on our website or quick Google search and get your spot now. A immersive hands-on 2-day training. The best training is on-the-job training, and this simulates a true immersive environment. It's not just lecture. So check that out. Now, we're not going in detail about some of the topics that are going to be important in your architecture, your DevOps environment. One of those details that's very important is your SQL Server database or any type of database. And it's very different from a compute component where you can just wipe out the files and put it back and start it up because there's no state. But when you have state, it needs to be modified in a different way. It needs to be managed in a different way. And so there's a past webinar that I did jointly with the founder and CEO of Octopus Deploy, Paul Stovall, and you can find that at bit.ly/Octopus Database. And that is the recording of the webinar specifically on database DevOps with using Octopus Deploy. And we talked about state-based versus migration-based approaches, rollbacks, zero downtime. We talked about so many things. Check out that recording of that webinar because the database certainly is a very specific concern for DevOps environment, and it must be there. If you have a DevOps pipeline and you say, oh yeah, we're automated, oh, except for the database, you're not automated. You need to be completely hands-off. You need to be able to commit to a Git repository and let it flow and have it be, It's okay to have an approve button, like, oh, now it's time to go to this next environment. I hit approve. But beyond that, it should just flow every piece of your software system, including the database. All right, so let's talk about the objective. Now, just looking at the job titles of the people on this webinar, you all are leaders. We have managers, architects, lead engineers. We have a whole smattering, but you here on this webinar, you are the leader. And your job is to guide and direct. With the right strategy, things fall into place. With the wrong strategy, no level of execution is going to make it great. It's going to make it work well. Now, architecture is a special type of strategy. It's the technical strategy. Now, there's three types that we can break this down. One is the design of the system. That's part of architecture. The second is the design of the organization that builds the system. That's organizational architecture. The third is meeting budget and schedule targets, because how you choose to structure the system really hugely affects budget and schedule targets. You've heard that you can build a 4-bedroom house for a small amount of money, and there's no limit to the amount of money that you could make at this palatial mansion of a 4-bedroom house. Okay, so you can design the same thing functionally and be targeting a whole different set of budgets and schedules. And so those are the three different types of architecture: the system, the organization, and the budget and schedule. And so DevOps, it helps give us a model to ensure that we identify all of the needed architectural elements. There are the three ways of DevOps. If you haven't read the book, The Phoenix Project, you need to. But the three ways of DevOps are flow, feedback, and then continuous learning. And flow is all about the flow of changes all the way out to environments. Feedback is the quality checks, every quality control gates every step of the way, because we make mistakes, we need to find out quickly. And continuous learning is that loop from all of your environments back into the planning for the next change. And we'll talk through those. Because this is a talk about architecture, okay? And these things are really important. Now, it's common for us to quickly think of architecture as just the structure of an application, and it is. But now think about this. The DevOps environment is a system. It is your manufacturing plant within which individual applications are built, application features are developed. You know, just a month ago, there was another Tesla event where Tesla rolled out its new pickup truck that it's starting to work on and maybe ready in a couple of years. But they talked about building the cars, and yeah, how it was really hard and really tough to design and build all these cars, but that the more difficult system was actually the automated manufacturing plants to produce the cars, and that the manufacturing systems were actually were more of an investment and more innovative than the actual car itself. That's a good analogy for what you as the leader are thinking about when you're looking at your DevOps environment. That is surrounding your developers with a high-performing manufacturing plant where features and applications can be developed in a really quick manner with high quality. But that entire environment is what we're talking about right now. And so design this system, design your DevOps system, and not just the .NET application, all right? So broadly, we think of a lot of other capabilities other than just the DevOps automation. Now, in this diagram, it's a quick model of how we think of DevOps-centered software engineering. The DevOps pipeline is at the center, and certainly code changes and features and new applications need to be automatically built, tested, deployed, environments provisioned, and that pipeline needs to be developed. But around that pipeline are the practices that you choose, the methods for defect removal, the workflow you put in place for your team, how you communicate and describe your architecture with multi-layer blueprints, just like a civil architecture, and then how you go about operating the resulting software applications that are running in the Azure cloud. And ultimately, you want to wrap all of those in a cycle time of planning a change, coding, integrating, packaging, release, operating, learn, and you want to spin that cycle faster and faster and faster. Now, to do that, for each of these capabilities, including the DevOps pipeline and all the other capabilities, you need a sound strategy. You need that strategy to be executed with discipline, and then you need to measure how it's going so that you know that you picked the right strategy, and also give you insight into when you need to either change your strategy or alter some aspect of it. Okay. Now, by the way, if you've attended any previous webinars, you've heard me say this before. Best practices is a loaded term. There are so many practices that have been labeled best that it is logistically impossible to use every single one of them on a given software project. There's just too many. Some of them overlap. Some of them are alternatives. And so it's all about choosing which practices are appropriate. Okay. It's the choice of practices, because obviously no one uses every practice that's been labeled best, just because there's too many, which is a good problem in some cases. Okay, so this is a high-level overview of what we're going to go through. This is a highly shrunken technical blueprint for the structure and the flow of a pipeline. Now, in this example, it's implemented using Azure Pipelines for builds, and then Octopus Deploy for the deployments. And it has a continuous integration build. It has a 3-tier deployment pipeline. I want each of you to have this. So we're going to be posting the download link in the chat. And if it doesn't work for you, send me an email. I want you to have. Now, this is just the top third of the architecture poster, and you can print it out at your local print shop, 2 foot by 3 foot or larger. This is the overall architecture for an automated DevOps pipeline with this mix of tools, and it shows where the 7 key steps fit in. We're going to go through each of them, and I'm going to talk about how each of them must be done right in order to have success with an Octopus Deploy implementation. And I'll just give you a peek at what the complete poster looks like. I understand there's no way that you're going to read it on the screen, but we'd love to send this to you. So go ahead and request that and get the download in the chat. Okay. All right. And just a quick agenda as we dive in. These are the 7 key elements that we're going to quickly move through. We're going to start right at the beginning with essentially planning and design, the pre-code design process. Then we'll talk about how you need to structure your source control repository in order to enable Octopus Deploy to work properly. Because if you think about the DevOps pipeline in the water metaphor, with water running down a pipeline, you want a smooth, continuous flow. And think of the quality gates as filters in that pipeline to keep impurities from getting to the end. But think of the Git repository as the headwaters of that flow. It all comes from the Git repository. And so that needs to be structured properly. We'll touch on where full system testing fits into your pipeline. We'll talk about user experience testing and how that relates to the pre-code design process, releases, production releases, and how to observe what the system is doing in all the different environments. Okay, this is the overall process view for your pipeline. And actually, even if you're not using Octopus Deploy, I don't care what tooling that you are using, your process is going, it needs to generally look like this. You can call these stages different things, but it needs to generally look like this. The top 4 are essentially figuring out what to do. Conceptual definition is the old requirements. What objectives are we trying to meet? And then user experience design is, what is it going to look like? How is a human going to experience things? Even if it's a back-end service that's moving data between one system or another, do you expect data to be in the downstream system within 30 seconds or 5 minutes? That's part of the user experience design, because if it's 5 hours and the data still has system, some person is going to have trouble doing their job. So that's the user experience aspect of it. How is it going to feel? How do we interact with humans? That's the human to software interaction. Then technical design is where you determine, are there any new architectural elements that need to be discovered and added to the system? Are there any structural refactorings? Are there any additional libraries that we need to add to the mix in order to make this happen? Or even the research, the technical research to figure out, okay, I understand the requested change. How are we going to do this? And changes to database schema, this is where all those are decided. And then the acceptance criteria or test design. A lot of teams are using Scrum and the concept of acceptance criteria. The best form of acceptance criteria is bulleted test scenarios, where you literally say, navigate to here, click on this button, type in this stuff, click this button, go to this other screen, and verify that I see some type of success. And those in a very short bullet list, now we have something that can be developed into a full system acceptance test and then executed, because now it's an automated test. All 4 of those design decisions are necessary in order for developers to be able to move super fast. And, you know, as a leader, you want development to move fast. And by the way, most developers are really, really fast at writing the right code. We need to make sure that they are in a position where they're actually exercising that strength all day, every day, and not having to stop and realize, oh, I don't understand what we're going for here, the concept. I have some questions about how this is supposed to look or how this is supposed to be experienced. I think we need to pull in a new library here, but now let me go research what libraries. Or, hey, are there any negative test cases that I need to figure out? How am I supposed to test this so I know it's done? If a developer is having to stop and finish incomplete design, well, your developers are going slow, because guess what? They're not developing. They're not writing the code. They're actually filling in gaps with your planning process. So those are important. We also need to have some type of Git branching strategy with pull requests. I'll talk about that later. And then have an integration build. We need to store release candidates, versioned and labeled release candidates from the integration build in Azure Artifacts or some kind of package store. And then we need a minimum of a 3-tier deployment environment. And I'll tell you why. There are 3 distinct types of environments in a DevOps pipeline. And you can have as many of each as you want, but production, everybody knows production. You need at least one, obviously. A lot of people have multiple production environments if you have a different instance of production per customer. Or even if you have a hot site disaster recovery production, now you have 2 production environments. One just happens to be not used, but it's on standby. So you need at least 1 production environment. You need at least 1 manual test environment. UAT happens to be a really common name, user acceptance testing, but many people have multiple manual test environments. Other example names out in the wild are dev, test, sit, QA, staging, any number of names, but those are environments that are set up meant for people to go and check something in a manual fashion. That's the second type. The third type of environment, which if you don't have this type, you need to get this set up, is the test-driven development environment. It is the test automation environment. No humans are allowed on this environment type. It is meant to execute fully automated test suites. And so this is the first environment that we deploy to, because guess what? If the change we just made has destabilized the system or spectacularly doesn't deploy, doesn't start up, completely breaks, it makes no sense to push it to a manual test environment, because then we're just wasting someone's time. And so even if you don't have any full system tests that exercise the functionality of the system, even just having 1 test that does something to make sure that that your application can still deploy, can still start up, and we think that it can run and do something, that is going to speed up your team, because that is going to eliminate the instances where you deploy to one of your manual test environments and then it just doesn't work. Okay. And so you need at least 1 environment of each of the 3 types. Again, the three types are your test automation environment. We call it TDD. The manual test environment, we call it UAT, and the production environment. Those are the three types. You need at least one. You can have as many of each type as you want. Run them in parallel, run them in sequence, your choice. And then finally, we need to have a capability, a formal capability to operate and support our application in production and in every environment. And so observability is the key word. The question is, do you know what your software is doing in every environment? And do you know the people who are using the software and what they are doing in every environment? And you should have that understanding without having to have someone with production level administrative credentials go onto that environment just to extract some logs or some information. So we need to pull that information away from the environment. Now, this is a zoom in of the pre-code design process and what it looks like in a Kanban style board. Pretty much all the tools these days use a Kanban style board. And so a minimal development process will be roughly about 9 columns on your Kanban board. So if your project is not using 9 columns, take a look at that, figure out what you're missing. Now let's talk about the Git repository. Here are the things where if you get this wrong, your Octopus Deploy system will not work. It will be clunky. You're going to be fighting against the natural order of how things are meant to go. And pretty much every DevOps tool out in the marketplace, even on the Linux side, all the ones they've seen, operate with a certain set of assumptions. And here's the assumption. The assumption is that one Git repository will produce one versioned release candidate of something that deploys together, okay? So a Git repository can have an application that has multiple runtime components, and that's fine. I'll give you an example. A web application, some type of offline batch job, and a SQL database. Those are 3 independent components that run in separate memory spaces, probably on separate servers and different Azure services. They all 3 need to be deployed, but they are part of the same application. And therefore they have labeled as part of that application, the application name, and with the same version number, okay? But they're 3 deployable things. So your release candidate for the application will consist of 3 NuGet packages that all have the same name, but then have the component name, like website, and then have the version name, okay? So you'll have 3 NuGet packages, but that represents the same release candidate for that application. So, so if we start with the Git repository in the center, the Git repository needs to have one versioned software application. In Visual Studio, it's really easy. That means there is one Visual Studio solution and everything is in it. And it's okay to have one or many web applications or one or many batch jobs or one or many SQL databases, but it's all part of the same application. It all changes together. It all gets tested together and all gets deployed and operated together. And so that version software application has one software build that produces the release candidate. Now, a software system in general can be segmented into multiple version software applications. And certainly if you're using any microservices patterns, you've taken a software system that that maybe you could fit it all into one big Visual Studio solution, but you've decided, you know what, let's break it up. And so let's take a case where you have a software system, you break it up into 3 independent applications. That's fine. Each independent application is going to have its own Git repository, okay? And then from a team perspective, you don't want to have multiple unrelated teams committing to the same Git repository because people step on each other. So if you have a software system broken up into 3 Git repositories, then each of those Git repositories with its single software application is going to have its own integration build, and which then flows on for the rest of the pipeline. So if you have a software system comprised of multiple applications, you're going to have multiple Git repositories. The Git repository is the headwaters of a DevOps pipeline. So if you want to know how many pipelines you're going to have, you count the number of Git repositories, because you need one pipeline per Git repository. Do not have multiple pipelines just because you have multiple branches of a Git repository. That's a big mistake. You need to let your branches be these alternate dimensions and operate on the same pipeline configuration, but just using variables or some tags. That's a topic for another discussion. But every Git repository starts and begins a DevOps pipeline. Okay, here's the process that a integration build needs to go on in order for you to be prepared to use Octopus Deploy to deploy these things. So first of all, you're going to commit after your private build, and then you're going to auto trigger your continuous integration build, which is going to essentially do the same functions as a test-driven or a TDD test: arrange, act, assert. And so getting ready, which is arrange, you're going to clean up any artifacts from the past builds. You're going to stamp a version number on everything. You're going to set up the environment, which in a lot of cases is migrating your database. Then the act is converting your source code to executable format, which in our case is a compile. It's a .NET.exe command. It's an MS build command. And then after we do our compile, and now we have executable format, we have assemblies, then we're going to do asserts. We're going to run our unit tests, which execute fast because they don't call out of process. And then we're going to execute our component level integration tests, the ones that can run quickly and only have a limited set of dependencies. For instance, calling from your .NET code into SQL Server, make sure the schema is right. That's an example of an integration test scenario. Then we need to get more information via static code analysis. We need to publish the test results, and then we need to package up the deployable application components into the right packaging. That's where we have MS Build or .NET.exe do a publish operation, so the appropriate files go into a directory. Then we use octo.exe, the Octopus Deploy's packaging tool, to take that directory and create a deployable NuGet package. And then we need to publish those NuGet packages, which essentially together are a versioned release candidate for this particular application. Okay, and then of course, release candidates can be deployed to any number of computing environments. We're not going to go into these options, but there's an array, and it doesn't matter which one you choose. If you're physical servers in an on-premise data center, or if you're completely serverless with Azure App Services or somewhere in between, it doesn't matter the environment type. We can deploy it with Octopus Deploy. So there are two options when publishing and storing and archiving your release candidate. Those NuGet packages can go directly into Octopus Deploy, or they can go into Azure Artifacts. Now, here's a caveat. Octopus Deploy's built-in NuGet server is specifically for deploying via Octopus Deploy. You cannot put something in the Octopus NuGet server and then use another NuGet client to extract it. So this is important when talking about full system test suites. So your functional acceptance test suites, your security penetration test suites, if you have say an OWASP top 10 test suite, or an ADA compliance test suite, or testing for screen reader compatibility, any of these number of test suites that have to operate on a fully deployed instance of your software, those test suites cannot be packaged and deployed into Octopus Deploy unless you intend to deploy the test suites with Octopus Deploy. If you're using Azure pipelines to run your tests, you'll want to take those NuGet packages that represent the test suites, put them into Azure Artifacts, so that your hosted agent in Azure pipelines can be the NuGet client, pull it back, open up that test suite, and then execute it against an instance of your TDD environment. So that's something to keep in mind when thinking, hey, okay, what are my options and where can I push the release candidates? If you're using Octopus Deploy to deploy the test suites as well, then great, push everything, all of those deployable packages into the Octopus Deploy NuGet feed. Okay, so here's a zoom in of part of the architecture poster illustrating what happens in each of the different environments in each of the steps. And I can't stress enough, I'm not going into databases, but in the TDD environment, We need to be recreating the database from scratch every time. We need to be recreating our environment every single time, reconfiguring the environment every single time. That proves that every step of the way, we understand how to create an environment, how to provision it, how to configure the environment. Because in the DevOps world, everything's repeatable. We want to be able to move fast. We want to move around. And we do not want to make the same mistakes of decades past where we create an environment that down the road, our team members need to change something and they don't remember how it was put together. And that's already happening in AWS. That's already happening in Azure, where people use their mouse and a web browser or even command lines, and they piece by piece manually kind of assemble this environment and create it and then start using it. And then down the road, we say, oh, let's create a new environment. And then, oh, shoot, well, how do we recreate this thing? Or I don't understand why it's working this way. With a software build, if we break something, we can roll back in source control and just try again quickly. We need to have that same capability with environments. If something goes wrong in an environment, just throw it away and recreate the environment from scratch. That needs to be your modus operandi when you're talking about pre-production environments. For pre-production environments, you throw it away and recreate it from scratch. We need a little bit more process around production environments because we have active people on the environment and we have production level data. But for pre-production environments, it should be just as quick as source control. Let's roll back, let's blow it away, let's recreate it, and now let's try again and move on. All right, now let's a little bit of implementation detail just so you see how it works. When we're looking at Azure pipelines, you see we have a 3-stage pipeline configured with TDD, UAT, and prod. I'm not showing an example in YAML just yet because YAML just came out in May, and some of the areas are still being worked on. So I'm using the existing designer base you can see, but there's 2 integration strategies with Octopus Deploy. The first is a fire and forget, where you don't have any deployment logs. You just kind of kick it over to Octopus Deploy and then use the Octopus Deploy dashboard to carry it on from there. The downside is it does not allow you to run automated test suites because now Azure Pipelines has no visibility into anything that's going on in the environments. So the second strategy is orchestrated, which is shown here. In this way, the Azure Pipelines does have a mapping of what environments exist, but we delegate to Octopus Deploy for it to do all of the work. But in this way, all of the logs are streamed back from Octopus into Azure Pipelines so that we can see test run logs and deployment logs in one form. Also, if you're using Microsoft 365, that allows approval level of, clicking a button, I approve this to go to production. It allows that for stakeholders who have Microsoft 365 access without having to give, say, someone on your management team access to a button in Octopus Deploy directly. And so what's most important is that tests can be run in Azure Pipelines. Okay, now here's a caveat. A lot of the advanced Octopus Deploy scenarios have no parallel in Azure Pipelines. For example, tenants and channels just don't have a representation in pipeline. So the normal day-to-day cases work fine, but when you're dynamically provisioning and configuring environments and creating parallel environments, you'll have those deployments happen in Octopus Deploy without tracking in pipelines. But the main line from master all the way to production, and then approval steps to, say, go to UAT for testing, or approval button to go to production, you can map that main line here, and as well as all of your TDD environments. Now, if we dive into one of the TDD deployment steps in pipelines, this is all you need, because we have a task essentially to delegate to Octopus Deploy to do the heavy lifting, and we're passing in the release number so that we're telling Octopus Deploy, this is the release number to actually deploy. And then we're adding in some additional octo.exe arguments so that we can take pipeline variables and flow them through so that they can become Octopus variables, so that we can determine where a particular variable needs to live. And then after Octopus Deploy has deployed the application and all of its components to our TDD environment, Then we go on and download the package for our test suite. We poke in some configurations into the test suite configuration, and then we use the VS test step to execute our full system test suite, which in this example and the example in my book, runs Selenium tests and opens up the browser on the server and actually clicks through functionality in the application. And then subsequently, for other environments that don't run tests, all we do is use the deploy task. Now, specifically when you're integrating pipelines or TeamCity or Jenkins, use the deploy task, because then you can specify the exact version number to deploy, whereas the promote task tells Octopus Deploy, hey, go ahead and guess what is the next version in order to be deployed. Whereas if you use the deploy task, then you specify concretely, which also allows you to redeploy previous versions as opposed to always going forward. Okay. And I wanted to show you just in Octopus Deploy what it looks like to enable one of the pipeline variables to receive that information from pipelines. That little checkbox that says prompt for value, you must check that box, or even if you pass it in command line using octo.exe, Octopus Deploy is not going to be looking for this value incoming unless you check that box. Okay. So I just want that is the caveat, because there's a lot of variables you'll want to define closer to your build configuration, whereas then there's other variables you'll want to define in the Octopus variable list and in those library sets. Now, this is what the process will look like for just a two-component application that has a SQL database and a website. It's very simple. The first thing we do, if necessary, is do some human approval. If it's a downstream environment, and of course I have it. You can see that I have it disabled, but just for example purposes, you put a human approval step, and it'll kind of stop and wait for you to hit a button. And a human approval step can be an Octopus Deploy if it's more technical in nature, or if it's more business in nature, you can put it in pipelines. The next is actually about telemetry and knowing what's happening. We want to put in a marker so that we are telling our application performance monitoring tool, in this case, Azure Application Insights, that, hey, we're starting a deployment. So we want to add a deployment marker and have that be recorded in our logs. Then we grab the database migration NuGet package and use the deploy and post-deploy PowerShell scripts that are in there and essentially execute our migration tool, which the migration tool will be inside the package, and it will be the same tool that's used in your private build in your development cycle and in the integration build to create it for running component level integration tests in your continuous integration server. So there should be no additional logic in Octopus Deploy for how to migrate your database, because it should just be reusing the same tool and the same scripts that you've used in your integration build and that you've used in your private build, running it on individual developer workstations. So it's not special logic that has to go in your Octopus project. It just leverages the same thing that has been put into the database NuGet package that is now being pulled. And then for deploy UI, Octopus Deploy has everything built in to manage web applications, soup to nuts. It's absolutely amazing. It's absolutely automatic. All right. Now, I want to talk a little bit about variable architecture. A variable is a piece of data. So you have to think, who owns it? Is the system of record the build system, the build server, or the deploy server? Or is the system of record some external system where data needs to be pulled in dynamically? So think about the dry principle. Don't repeat yourself. If you don't create a strategy for configuration management, then you're rolling the dice on a management nightmare in really short period of time. Every system has configuration management needs, and you as the leader must design it. Remember, design doesn't just happen. It has to be intentional. And every application is probably going to have pages and pages of these variables. And so don't just let it be an implementation level decision of adding additional variable. Intentionally structure a hierarchy of variables. And anytime you see the value of a particular variable being duplicated, use that as a chance to build a dynamic variable. For instance, you notice that we have the database name coming in as a variable passed in via octo.exe, which that's what this is, a prompt for value. It's coming in from our build server, and then our connection string, which has to be in a web.config file ultimately, is built up using the database name that we have specified and are pulling in. So if you can dynamically create the value for a variable, do it, okay? All right, let's talk about full system testing and the flow of what happens. So I'm gonna go all the way back to even before code happens. In our pre-code design process, we're gonna specify the test scenarios in our acceptance testing column in our Kanban board. Then with that information, the engineer is gonna do the feature code and develop the test code, which for web applications is likely gonna be Selenium test scripts. Then the engineer is gonna execute a private build locally on their workstation, know that they haven't broken anything, do a git commit and push it to their feature branch. Then the build server is going to execute the integration build and then package up a branch level release candidate. You can consider a alpha release candidate. These release candidates functionally work the same way, but because we mark them as coming from a branch, they'll never make it to production. But we still need to know that they deploy, because what if I break the deploy? I'm not ready to merge to master. So then we actually do a deployment to an instance of a TDD environment with Octopus Deploy. Then our automated acceptance tests that have been developed for this feature run along with all of the other ones. Then once those pass, once we know that it builds, it runs, and it not only runs in a real environment after a deployment, but all of the full system tests run, then we know that we can create a pull request. And then another person on our team can execute the team's determined inspection checklist for evaluating a pull request, and then they can hit the approve button, which then all the code will get merged into master. And because it's a new commit on master, a master level integration build will run a deployment to the TDD environment, executing all of the full system tests on the master branch and giving us a go ahead. And only then will it be up for grabs to go to a manual test environment. And so when we think about defect removal, that's the flow. In the test design column, we specify how we're going to test this from a full system perspective. And in functional validation right after development is team level testing, which includes the full system tests and includes the pull request formal inspection. So I talked about running the full system tests in Azure pipelines, for example. This is what it looks like, and we're actually using a attachments feature, which, because we're opening up a browser running Selenium tests, we're taking a screenshot of every step along the way. And if I zoom into that screenshot, I can see that this is the body of the web page right here, with a form and some text boxes, some buttons. And these are 3 attachments, one after another, so we can see what it looks like. Whenever something goes sideways, whenever one of these fail, these screenshots are going to be really important, so that you don't have to redo a whole bunch of effort and time just to reproduce the problem and see what happened. Because oftentimes, just looking at the screen, we can see what the problem was. So as we're deploying, and as you're configuring your Octopus Deploy process for deploying to different environments, this is a table of common tasks that need to be executed on each environment. And you can see a theme. We do less and less as we go to production. The principle is that you never execute something on a production deployment that hasn't been done the same way on multiple environments previously. So everything that we're doing in production has been tested multiple times in production in environments upstream from production. That's really, really important. And finally, I'll close out with telemetry observation. We want to make sure that logs and information from every deployed component of our application make it into a centralized repository that can be queried. Azure Application Insights is great. There's also plenty of other tools. There's Raytrace, there's Stackify, there's Datadog, there's New Relic. there's a lot of great tools, but from an architecture perspective, make sure you're getting all the information away from the environments and into a place that's accessible, but at the same time that you're not logging any sensitive information. Okay. There's also 3 types of telemetry you need to think about. We've gone webinars into this, but everyone knows logs. It's just regular text of what's happening. But if you add metrics and events to your telemetry types, then you can actually build up a data warehouse of information that can be queried and analyzed using the same business intelligence tools that other departments in your company use. And so events are names for the features or names of actions, they're strings, and metrics are numbers. And so if you take those 2 together, that's essentially the same thing as dimensions and facts using the Kimball method for data warehouse design when putting together fact tables, which are the center of a star schema. So in this fashion, you can leverage the same data science methods for gaining more observability of your system just by emitting information in this way and then getting the information away from your production environments. And I showed you a deployment marker. This is Azure Application Insights. Just by hooking it in and using the .NET Framework, you get a wealth of information even without adding any kind of tracing statements. And then when you put in the application marker, that's what you see in Azure Application Insights in the performance view. You get a marker that says, hey, I just did a deployment right there. So now obviously there's not much traffic in this environment, but if you see performance going wonky right after doing a deployment, then you know what happened. If you click on that marker in the Azure portal, this pane will pop up telling you exactly what version got deployed from where, with a link back to Azure Pipelines where you can look at it. And then Azure Pipelines implemented with Octopus Deploy, you can navigate over to Octopus and see all the information. And with all of the logs flowed from Octopus into pipelines, you'll have a wealth of information at your fingertips really quickly. So that's the 7 key elements of a DevOps environment. You need to have every single one of those in your DevOps environment. I know that there's a lot that goes into this. If you want to dig in further, you really need to come to Austin, Texas to our .NET DevOps Bootcamp. Every one of these you will do firsthand, hands-on. You will leave with all of this set up in your own accounts, and you can come back to your team. You will have it set up. We'll go through Azure Pipelines, and we'll go through with Octopus Deploy. We'll be putting those 2 together, and not only will you see it happening, you will have done it. Okay, so go ahead and do that. All right, we have so many clients that have been helped by this. There's a few examples on our website. We have some video testimonials. Go to our website to check those out. Just the impacts are tremendous. Our goal is to make you self-sufficient. We're a software architecture company. You have a development team. You are executing a development project. We know that you and your team have what it takes to deliver world-class results. You've got what it takes. You just need the right methods. You need to put it all together in the right way. And we want to help you go in that right direction. And so that's our goal. Our goal is to make you self-sufficient, to up-level you, to equip you these skills and tools. And that's what we live for. So we know that you have what it takes. And regardless of what challenge you're facing now, you can do it. You just need the right direction, the right strategy, and the right guidance. And so, so reach out if we can be of any assistance there. One easy way to get some help is to have us do some architect level advisement or consulting. Actually, until Christmas, we have a free 30-point inspection offer. We still have a few spots left that we'll be scheduling right after the new year. But if it would be helpful to have a professional come in and inspect your current DevOps environment, we have a 30-point inspection checklist where we go through multiple points in each of these 7 different areas. And every gap we find, we give you concrete recommendations for hardening and filling in that gap and getting better in that area. And so we normally charge $5,000 for this service, but we have a few more before Christmas. And so be quick about it. If you would like us to professionally inspect your environment and give you our 30-point DevOps inspection report, then reach out. You can email me. That would be the best way directly, just to make sure that that we connect. So ultimately, you are running a software organization. You need to be self-sufficient. You need to have all these capabilities, and your team is run by you. So consider us your guides, and let us know how we can help. The contact information is right here on the screen, including my phone number, and email address, and you can look at one of our project jumpstart stories here, helping a new software package get off the ground so that then the development team can really rock and roll. So thank you so much. I think I answered all of the questions in line, and I appreciate the attention. I know this is a lot of information, but good luck with your Octopus Deploy implementation and your DevOps journey.